Welcome back from the short break. Before we went on break, we saw the pain which we could face when we try to model Cassandra tables for analytical workload. Now, the first pain is that we can never comprehensively and conclusively uh, tell how the user wants to query the table. So, for instance, we're doing very good test. What if the user want to look at things from the make and model dimension? What if they want to use the cylinder capacity to understand how many percentage of cylinder capacity passes or fails based on other criteria by date? You see, there's not an end. It's in essence what I'm trying to say. There's not an end to to there is not an end to what the user, we can put a restriction on what the user wants to do. From an application perspective, there could be an end. For example, you can have a workflow. You write a table, you look up the table by this, from an application, because the application has a particular workflow, we can build the application based on that workflow. That is why Cassandra does it excellently well when it comes to that space. Writing data in, getting data back, from an application perspective. But from an analytical perspective, there is just no way to conclusively say I have taken care of all the clients requests, especially as the table even gets larger. If we're using a table of just 5 columns, it will be basically easy. So for instance, if we were writing and reading trading data, we know we were dealing with the instruments. So whether it's currency pairs, that would be instruments, date, the ask price, right, and the bid price and the volume, right? So if you were dealing with pure trading data, this will probably be everything else you need, right? The instrument or currency pairs, gold, US dollar, dollar crude, gold, silver, cotton. That's the instrument. Date is the date time that price tick was released. The ask price and the bid price. The volume. What else you don't think? Now this is simple. So you can ask by, these are literally primary keys. Another place where Cassandra will basically excel without much consideration here would literally be in time series data, right? Time series data. So let's look at it, right? In time series data, you have date time, right? You have the label, right? You probably have a tag, and you have the metrics, right? This metrics could be more than one, and here you can literally have it as a map, right, of the metrics and the metrics label, and or you can just have the metrics only if you're working with only one metric. So in this case, there's a little upfront you have to think, right? But it's simple at the model. But now we're working with data that can be literally having more than 10 dimensions for which you don't know which and in what order the client wants to um, do that by. So we settled for something very naive, and like I told you, naive from the analytical perspective, and we are going to use Spark to write into this table and try to see if it's gonna work. So let's do it the same way we did it, and that is create this table and open a Spark shell and try to write this code in this. Try to read it and write the same query in Spark shell. How about that? So we are going to create this table, and let's keep this trial still very necessary. And in this case, I could literally take everything out, but I'll just leave it this way. So this is what I wrote. Totally not vetted it at all, but I'm just gonna create this table. Describe tables. So drop table test item. So Having done that, I'm just going to create all the tables there. Good. Everything goes fine. Remember, totally naive. I just forgot the concept of how the table is going to be stored or how the table is going to be used because I'm looking out from the analytical perspective alone. Good. So if I say select star from test item, a query you should not do if you have big data. It looks fine. So I'm going to come now to Spark Shell, and what we want to try to do is see if we can just read that data frame and write a query, write queries against it, which we want to believe would work. Literally, it would work because once the data is loaded into Spark Shell, we're dealing Spark now. We're not doing Cassandra. However, Cassandra can also give us features like push down predicates, which makes our query improve. But then you want to think of it the same way we just did the modeling. If you want, how you want to use push down predicates, how you want to use some other configurations around in this Cassandra Spark integration, that would make stuff work. So having said that, let's just write a few code. The first thing I want to do is copy. I want to load the most important primitives, right? Once we're here, we'll say data frame is equal to spark.read.cassandra format, right? So we specify the table name. I think it's test results. I want to know what to put there. Nope. And I think the database, I think I called it movie lens. Then I'd say load. I just want to be sure I got load right. Is it load? Yes, load right. So enter. Good. So let's look at our data frame. Our data frame print schema. This is the table. So remember, one thing we can do is say data frame dot now I've forgotten the name of this method I wanted to use, and what we want to do is store it as a create. So first I would do it again and I just cache it, so I'm bringing it to memory, right? And say data frame dot create or replace temp view, right? So we want to call it tests results. Good. So we are now totally in the range of where is my query? Cassandra query. So I'm just gonna copy this. Let's say value query is equal to cool, and I'd say spark dot SQL. Just something I like doing. I just say run spark.sql, and we're putting query in there, and we'll say dot show. Or yeah, let me do what I have in mind. Let's call it run, a method that's called run that takes a string and does nothing with it except that it uses spark.sql.run the query, and it shows let's put a very large, let's 1000 is okay, and truncate is equal to false. So we just want to create a method called run, and we use it a lot. Paste, and so we want to say run query. So we copy our query, so test results, and let's run this query. So there's no record in, but we just want to prove that it works, right? So this is where Spark goes to the Cassandra table we have in the other host and tries to get all the results for us. Cool. So we could not get it. We could not even do this with Spark. Now, as you keep doing it, the more you do that, you get better performance. Especially if you have a large RAM in your cluster, these records could be persisted to memory or persisted to disk, because we're using cache there. So we can agree this works, right? And now our users can literally do anything. For example, let's run a different set of query. Select make count. So let's just call it make count from test results, group by make. Still gonna give, we now have that total liberty. We have that total liberty to do this stuff. So that's where we have it. And once we've seen a way out, we can now do our data write workloads, intensive data write workloads, and in the other hand, we can do our analytical workloads. Two separate places, two different behaviors. Now the question is, what about the performance? Now, when you come to the level of performance, that is when we can even go further, especially as our data increase, to look at how we can use different options, different configurations. Like I said, things like predicate push down to even make the data better. Now, remember, from the right perspective, we can still spread out our data in a way that can make it even more easier for the user. So that when we write queries like this from Spark, Spark doesn't have to force Cassandra to contact all the nodes in the cluster. We can still contact just a few nodes. But once we've lifted the data into the Spark compute engine, we are now totally free to execute the queries as we deem fit. So having done this, we now have the next item on our list, and let's write the data into those tables that we just did. So the last time we worked in this, we created a function called create tests details with the group hierarchy, and it worked. So we also have another one here where it says create the test result model, right? And so the test result model, I think I should just show you the full code. So the test result model, if we come back here, what we did was we collapsed all these lookup tables, because we don't have lookup, into this one test result. So we literally have everything here with what here. So that's just a pretty way of saying we denormalize the data. And we denormalize the data, but that's not all. We also second. Yep, we denormalized the data, and we projected all the values as we have in our new domain test results, and that is it. So we can run it two ways, and at least at the end of the day, at the end of the session, we're gonna run it as a jar. We're gonna do that, running it as a jar. But for now, let's just use our shell to execute all these commands. So what I'll do is rough notes. Cool. So I will copy and run all these commands right here. Good. So what we're doing here is reading the lookup tables, right? We're reading all the lookup tables. Then we have a function that will help us get our schema from the file. Like I said, these tables are large, so we don't want to infer the schema, and it's not like we knew the schema beforehand, so we had to prepare a schema, and we save it as part of the project. So the schemas are here, but for this time, the schemas, we drop them here, so we just want to read them. excuse me, and put them as part of the, and read them to infer this, what the schema looks like. So we're going to get the schema from the file and we are going to execute. So read the schema from the file. Now we're reading the test results. We're reading the test results and the test items. Okay, good. So once we've done that, we will skip this test details because that's what we did, and instead go to generate test result function. So I copied all these from the application itself, right? So we'll look at the application later. So now we have a function that can generate the test results. Then we will create a data frame and we'll call this test just call enriched test results data frame. Cool. So enriched test result data frame, paste it. So we're gonna do a bit of reconciliation here. Let's reconcile what this schema looks like and what our model says it should look like, because I haven't done any correction analysis. So we come here and we'll say we have test ID as an integer, we have vehicle ID, we have test date, we have test type code, we have test result code, test class ID, we have test class ID, we have mileage, post, make, model, fuel type, cylinder capacity, and these other types right here. Test type, test result, fuel type, code, fuel type. Okay, so it looks like we took care of everything. We also need to do another level of reconciliation, and that will be, I just described test results, right? And I'll bring it once again. Test type is integer. Okay, so this is where things go match. Test type is integer. Vehicle ID, say it doesn't follow the exact order. I prefer things being in the same order just because it leaves you less room for debugging, right? So what I'll do is I will recreate the table to just make sure I follow this order. Now, remember, the most important thing is your primary key, right? And remember, when Cassandra stores it, it doesn't follow the order, right? Cassandra will store things lexicographically, right? But we just want to make sure it's easy for us and let Cassandra do that heavy lifting. Let's just follow the order. So, so that I debug less, right? So I'm going to come right here, and where is my stuff here? So this is where it gets interesting. So I have test ID, I have vehicle ID, then I have test date, then I have test type code, then I have test result code, I have test class ID, I have test mileage, postcode area, make, model, cylinder capacity, first use date, test type, test result, fuel type code, fuel type. Remember, I don't need to change primary key definition. Yes, I literally don't need to change primary key definition because we're not building anymore for analytical workload. However, you can still break down this. You can still break this further. I mean, I could do a lot more modeling, but remember, it's to support different types of analytical workload. For example, I could have literally added year, date, month, right, and done something like test class or test results code. So we want to know pass and fail, and we want to know pass and fail, and we want to put that into year, month, so that things becomes easy for us to take on. You want to do those kind of things, but once it depends on the kind of analytics you want to do. Remember, test result handles all of them, right? And the way people want to look at those results, they differ. In the same way, I told you about um, indexes, and you see we created indexes. In the same way, you can help your workload by creating materialized views. So remember, when you start creating indexes, the more index you make, you suffer a little bit of write penalties, because that's something else to manage, the indexes in every write. So you can decide to use materialized view. So remember, two ways to do it. You can create multiple copies of the data, so you're having duplicates of the same data just for different read requirements. That is one. Another one, you can create indexes, and thirdly, you can use materialized views. So if we come from a business intelligence, a relational database warehousing background, a materialized view is a view that holds pre-aggregated values, just like it's a precursor to like a cube, pre-aggregated values. And the purpose of a materialized view is to speed up your analytical queries, right? It is somehow different from where Cassandra works. So a materialized view in Cassandra is it's not pre-aggregated, sort of. It's just you can use it for pre-aggregation, but that's not what intended for. It's to create a different view of the data, where you can order your where you can satisfy more read requirements by creating the way the data reshaping the way the data looks. So imagine if I have to create a data set, and I satisfied only one read requirement, and there are three more new read requirements that are closely related to my read requirements but are not thoroughly satisfied. So I can create a materialized view, right, for those new requirements, where I will, and this is the rule, you have to retain the primary keys you had there. Now you can add more to the primary keys. So you're not going to exclude new primary keys, because you'll be breaking ranks, but you can add new columns from the column family into that new requirements. So so if you have that kind of thing, you can literally point your Spark application to read from your materialized view and make things easier. And we're going to try that shortly, but it is one thing we wanted to point out: materialized view and how you can really improve the performance of your Spark application. So the fact that Spark can just load all the data does not mean if we have 1,000 nodes, we want to send Spark in there to pick everything, right? That is not too good for you, right? So we conclude that drop table test results, right? So we put if exists, right? So drop it if it exists. Copy, not here, this should be here. Cool, the table is dropped, and we'll drop this other table. So we'll take a look at test item later. So good. So it looks good now. So what we can do right here is now fire up and reach to do the write. Okay, so once we have that routine, we'll say we want to do some write, and once we want to do some write, we want to do that in Cassandra format. Remember, this is the short form for saying format. Then you put Cassandra inside of it. Then you say save, right? Save. The table is test detail, test results, and the database is movie lens. All right, so that does it. You save, save. So something didn't go right. Excuse me, I got it wrong. This should be Cassandra format, then save. Good. So found familiar table. Okay, so I got the spelling of Cassandra, test result wrong. This should be the correct one. Okay, so we found now we had we found a new column that doesn't exist, test mileage. So I thought my work was good enough. So let's compare notes once again. We had test mileage after test class ID. Did we have it here? Test mileage. So what happened? So let's look at it again. It says column not found in table, test mileage. So let's compare. Okay, I was wrong. It should be test mileage. So we will recreate. Good, and let's execute again. Now we have kicked up the job. To save time, let's just take a quick look at, we followed the same procedure when we did the test item data. And I will just show you in the code. So we look at it from the code perspective, and we will build our code and run that when the code is ready. So we structured everything into an application now. We have constants in our main class that point to, that gives the name of the files, of the schema files in our resource section of the SBT project. Now, when we run this application, we require some parameters. The parameters include the test result directory, the test item directory, the lookup directory, the Cassandra host, and the model. Then we want to see, we get these parameters, right? Then we initialize our Spark session, right? So put the name and we do configuration. So we want to take the Spark host and pass it there. The idea is we want to try not to hard code much, right? I want to try not to hard code much. You can even break things further. You can make all this configuration a part of your application configuration, right? So we import implicits because I love to use implicit functions and implicit literals. And now we read the test item. These are the two main guys we always read. Every year we read a value. And we also read the lookup tables. So we will get the model you want to read. So you instruct the model you want to read. And so the model could be class. In this case, you're doing the test details. Or you could be reading the result. In this case, you're reading the test result file. Or you're reading the item. In this case, you're reading the item file. So the results, the class we have seen, that's what we did in the first part of this course. We read it using the function and we wrote it. So in this case, I didn't use Cassandra format. You see, I just used the more verbose variant of that same guy. So when you see this use Cassandra format, this is what I meant. This is what it boils down to, right? So we write it. So that is simple if you say you only want the details. But if you say results, you're interested in the results. We read the results. We cached it. Now, if we read the results, it means I don't need the result here. Okay, good. That's fine. Then we enriched it, and that is what we just did. This is what we are currently reading. And finally, we write it. So I haven't done that part. So we can just copy and paste this part and say we are reading to key space, MOT key space, and we are writing to results. Good. That does it, right? For example, if you need more parameters, it would work. And to show you these parameters, for instance, let's go to data stacks. You see quite a number of these parameters. The split size, different ways to instruct. You go to the documentation, and you would see these parameters. Good. So yeah, but we left things at plain vanilla there. Then finally the items. Now the items needs the test result. So we want to join the test result with the items. So in this case, we didn't want to read the test result again. We didn't want to process the we didn't want to process the test results again. So we just read it from Cassandra, right? And use the value to enrich the test data items that we did we created a schema, and eventually you would write. So something like this. So this is going to be test items. Test items, and that is it. We write, we save, we write and save. If we don't find that, we're going to throw an exception saying we don't know what you're talking about, right? So everything within just follows the principle that we have that we've used, and this is reading the schema from the jar, and passing the argument and processing the lookup tables, right? So this is the application in a nutshell. While we are still building, now this is taking a lot of time, so that is why we intended to save time. We are going to try and build this code. So right here, we are going to say SBT, and we want to compile it, right? I haven't compiled it. We will compile it, create a jar, and copy the jar to the we'll copy the jar to the Hottenwork sandbox and execute it from there. But the first thing to do is to compile it. Okay, so this is taking time. Let's just use the Spark to see what is going on. Okay, this is going to take quite a lot of time, right? In the meantime, let's compile, make sure. Now, I'm not using an IDE. I basically like to use IntelliJ. I'm not using an IDE, but you can also compile using, and this is what I like using a lot. So yeah, we have tons of errors. So I like using these command and this syntax compile. So it gives me all the errors, then I can fix it while the errors run. So this is how I do it when I don't have IDEs. So I will start from line. Oh, sorry, this is rough notes. So we had a problem because there was a rough notes. Okay. So what I do is I am going to copy the rough notes out of here because it's compiling it alongside. Rough notes. I'm just going to add the word Cassandra. Cool. So I'm going to copy this and paste it here, and I'll name this one for easy understanding MongoDB. Good. That makes this rough note go away. Good. So once I've done that, you see we now have how many errors? Only one error, and that error is in line 87. Okay, so this is wrong. Save it, and all the errors should go away, but they didn't go. So we have more errors in 68, 80, and 87. 68. Okay, so this should be not df1. This is the problem of copy and paste. So I was copying and pasting from my rough note. Then this should be enriched. Yeah, another copy and paste there. And this should be enriched. Save. Let's see what we have. So we have one more test result model, Spark. So let's see, we come here, it's called Spark session. This is Spark session, this is Spark session. So this should be Spark session. Right, let's see. Great. So compilation completes. So we package, right? But remember, if we package, we don't have the we would lose the uh, the jar, the Cassandra library. So there are two ways to do it. It's either when we want to submit the application, we'll submit the we'll do Spark submit, and we'll do package to add the package. But you may run into issues with that, and it's not encouraged. So the best thing to do is to add SBT assembly plugin as a part of your SBT assembly plugin as a part of your build. So with assembly plugin, we're going to create a fat jar that should have Cassandra inside of it. So here I'd say assembly. So assembly will do package, but it will not add all the required artifacts into this jar, the big jar right here. So I'm waiting for you. So while we wait, we want to see what has happened. So far, we don't have a read yet. Right? Yeah, and this is just the sheer amount of data at work. You can also go and see if anything was written so far. Count test results. Yeah, it's going to take a while. So coordinator node timed out because it's waiting for replica nodes to respond because the consistency is 1. So yes, everybody's writing now. The consistency is 1. Everybody's writing, and that is why we have a. So right now because we have a default of 1 consistency, we have a problem. I could have said let's do this consistency any. Let's do any. So I have set the consistency to any. Once again, this is how you do it. Consistency any. It becomes any. And we hit that record, and you see any consistency is only required for writes. Right? Another option is to say consistency quorum. Did I spell that well? Is that how to spell it? Right there, we're still going to get that issue because it's waiting for a quorum. But it doesn't make any sense to do this because I only have 1, and that was why I set the consistency to 1, because the quorum is, there's only 1 node here, so the quorum is definitely 1. All right, so we can set things back 1. Right, good. So the consistency level has been, now this is what we'll talk about, flexible consistency level. Right? However, we could have improved the speed if we said specify the consistency of this Cassandra write format by saying consistency level, and let me check that. That should be, give me a second. Spark.cassandra consistency. I think there should be something like that. Just Google. So this is Google, and I'd say consistency. Yep. So the input consistency level. So if we came here, we would find that let's look for it. Consistency level. Yep. So you can set different consistency level: local one, local quorum, any quorum, yeah, two. You can do as much. So that's one way to tune it. And how do you do it? You can say spark.cassandra, spark.cassandra. So let me say one here to say config. No, you can do it from this level, but it affects all the rights. But I can do it for only one by saying options dot option. You can still say option. This is gonna be right any, right? This is the any part of it. This is spark dot Cassandra. Good. So this is some kind of settings where you do that, and this could improve. This could it could improve your write, but you could have quite a lot of dirty reads, right? Like you can improve your write and have a lot of dirty read, because this is like zero consistency, high availability, zero consistency. Okay, so write has begun, and we're still not going to get good result because we only have one node, and that node is totally being bombarded by by all by these calls. So but once this finishes, then we will be set to read. So we still await the Cassandra stuff, but we're not gonna end it here. You can just leave yours to run, probably take a walk and go do stuff, and use the same formula that we have used in creating the test results to test that this code, that the test item works. Given the time the test result works, the time it takes, you can imagine how much longer the test items are going to take. The test items are a lot more than number. There are a lot more records in the test item and test results. So usually time will sort it out, and in a much bigger cluster, and when I mean bigger cluster, I mean in a much bigger Cassandra cluster. Right, this will be fast. From the look of things, it is the write that has been overwhelmed. Right, the write has been overwhelmed, and let's see, the write has been overwhelmed. But if you were doing this in a real Cassandra cluster, you imagine the writes will be spread out, and no single node will be overwhelmed. I mean, like the load will be spread out based on the primary key, which is the test ID. You're just going to spread the whole work around. So you can only wait. But I think you've gotten the idea of what we're trying to say, right? The only thing we need to do now is to build this job, which is finally built. So we have one build, and run it using the appropriate command. So we will try and load that in. So we will try and load that in right here. This is where we have the Mongo. Cassandra, this target, Scala, splitting 1-0. Hold on. Sorry, got it wrong. Target, Scala. This is the assembly. We'll drop it right here. And we can't run it, but I just can show you how that should be. You can say spark submit, right, master yarn. Now the class has a name. The class is let's see what the class is. The class is app.main. App.main. You can specify other configuration parameters, but the jar here is mot Cassandra. Right? If you hit enter, Spark submit doesn't exist. It's going to ask you for all those parameters that we specified. Yep. So you should specify the test directory, specify, and the model to load, right? So you specify the class model. If you specify the class model, it's going to create, let's see, we're still not there yet. So time will solve this problem, and or if you create multiple nodes, for those of you who would prefer to use Docker, this would be a very, very good way to test this. So if you have enough resources on your laptop, I think you can use the, instead of install a local version, you can use the DataStax Docker. Use DataStax Docker image to kind of create your own kind of cluster. You can configure these to be in a ring. So imagine you create 3 different, if you have enough capacity in your machine, or if you have more than 1 laptop, so make it even easier, more than 1 laptop. So you put 2 Docker instances on one, you put 1 Docker instance on one, then you deploy your application on virtual on the sandbox to talk to these Docker items. So you can go through the Docker reference. This is another way to do the test, and you will see that the beauty of Cassandra actually comes when you are in a cluster, not a single node. Then we would not be doing anything better than using MySQL if we're doing a single node. Cassandra box. So Docker is another way to go. For those who have experience with Docker, this won't be difficult for you to set up a Docker instance, and see, you want to add Spark Analytics enabled with it. Just makes your work a lot easier. As a matter of fact, DataStax, the custodian of Cassandra right now, they come with the enterprise comes with analytics, Spark Analytics enabled, and they also come with search analytics. They come with a graph analytics as well, so that you can be able to use Cassandra in 1 or more contexts, right? And these are configured to handle these kind of contexts, apart from the read context that we've just looked at. So we will still see how far we are going with this, and we're 24 minutes in, but we are not going to wait. So having seen what you have seen, we have to, let's release this block before we can do an example of materialized view, before we can try an example of materialized view. But let's put it this way: having seen what you have seen, how can you make your own conclusions, right? When we had MongoDB, we had one big object that contained everything, literally everything. So the test results contained the test results contained the test item, because of the data model for MongoDB, right? And we saw that to a very large extent. You can perform analytics on much better on Cassandra, on MongoDB than Cassandra. For instance, we know already that we don't have test results defined, and we come here and say we want make. What would be a valid make? A valid make will be Iveco or Toyota. I don't know if there's a Toyota there, but let's just try. Toyota. Cool. So I'm just going to limit it to 10 records. Right. There is no index on make, but you see, this is MongoDB giving you that general computing feature, a general database paradigm feature, where I don't need to know. Now, this would have been, we tried to do this in MongoDB, and it didn't work until we created an index on make, right? So I can create index on make. I can say cylinder capacity is greater than, all right? Cylinder capacity is, put some, okay, no, let's just keep this. Cylinder capacity is, you can come and say, give me a second. Okay, cylinder capacity is greater than 1998. Is that what we saw here? 1998. Execute. We don't have an index on that, so that should take longer because it's going to do a scan of all the records and pick greater than and give me the first 10. Yep, that could be mod. But if it's a problem, you go create an index on a cylinder and you execute the query as such. So you have date queries, you have all kinds of queries that you don't pre-plan. MongoDB gave you that ability to do that, but we didn't get that much with Cassandra. The only way we could get that was we needed to use Spark Analytics for that. So let me see if I put 60 minutes to execute that query, if it's going to take that much time. Greater than or equal to limit 1. Okay, so we can make our comparisons, and great, this concludes. Let's see. Now this is another query that's now shouldn't take time though, because we are using one node, but let's see. Still timing out, still timing out. Still timing out. I don't know why that's timing out. Well, this would be a surprise why it's timing out. Describe test results. Right? Describe test results. Okay. So do we have a test ID I can test with to just check the ability of this to work? A second. Cool. Let's see a test ID that we can work with. 561089. 561089. Select star from test results, where test ID is 561089. Good. So this is a record. Now that's, yep. But why did the full count not work? Right. So we have records there, and you can read the result and check why. I want to know why this is timing out. Coordinator node times out, waiting for replica nodes to respond. Replica nodes. So let's see if I say consistency local 1. Let's do this. Are you still going to wait for replica nodes? Okay, received from 0. How about we look at what's happening here? This looks okay though. Okay. This looks okay. I may want to kill this for a while and see. But I'm just restarting the Cassandra server to see if there's any particular thing. Right, because that large count, I told you about the large count, it's a danger because you're literally scanning all the available, you're trying to scan the available nodes. So it's not a wise thing to do, but I still want to do it. Yeah, I still want to do it. Waiting for gossip to settle. So let's hit this and connect. Good, and we say use. So we use the wrong database, but it's okay. use Z movie lens, describe key spaces. Oh, sorry, I'm in the wrong space. Use movie lens. So let's hit this. Okay, so what is wrong to do turns out to be very wrong to do, right? We're not able to calculate all, we're not able to, it's waiting for more responses. However, we figured out that with this, if you use the primary key as it was supposed to do, that works. And we can use the same way that we built the systems for read analytics. So let's go back to the read analytics use case. Where is it? So the read analytics use case would work here. So what did we do? We said value data frame. So we said data frame df is equal to spark.read. And why did I close that? I can't remember what I did, but spark.read key space. This is wrong key space. Copy and paste is still a danger. So let's copy this. Right, and let's not even cache it, right? Let's just see how it works. So we say test result model dot create or replace temp view, and this is test results. But this is going to be dangerous if you don't have a cache. So let's execute this. Sorry. Copy and paste. So this is movie lens. Once again, this is how I get into copy and paste issues. So we want to execute this query and see what it looks like. Run the query. So that initial query we intended to run, that we tested, that works. Now we want to see it with data because we've loaded data inside of it, and we are going to be running that query. So let's take a look at the way it is executed. So we have 16 tasks in 2 stages. This stage will be jobs, show, DAG. So this will look up data from Cassandra, map, exchange, and perform joins. Okay, let's see how this goes. Yep. So this is where you need a scale out. You need a scale out. You need a scale out activity. So you can use the same thing, the same way we've performed it for test results. We don't have that much time to do it for test items, right? No difference. If you have errors, follow the same error pattern that we used. Remember, try the best to map the column names to make sure they're equal. Remember, we have issues because of that, so that you can be able to execute queries like this. This is one very powerful query that it doesn't come easy with other kind of databases, but you will get this with analytics well, right? Yes, to conclude, now we get no record. So let's do something. We get no record test results. So this is so embarrassing. Select count. Let's see if we even have any record here. Test results. We get. Okay, so now we get test results. Oh, sorry, it is my fault. So remember, this test is for 2005. Yeah, it is for 2005. So the date doesn't match. So this should be 2005. It was my bad. So this should have changed. Just for the sake of getting good results, I'm going to put these as 2005 and run it again, because we need to stop on a good note. Damn. So let's see what that looks like. So I have cached the results. That is why it turns out to be fast. So this is exactly what we get. We have test classes 1 to 7, and we got pass, pass, pass. And remember, we're looking for results in pass, failed, and I don't know what this code stands for, but this is exactly what we get, right? And now you can do all kinds of tests yourself. If we move it to 6, let's see, will it change anything? Right, paste and run query. Run query. Now we get speed. Good. So yeah, so this is passed with rectification at station. We get a lot more records. So now we can now perform ad hoc analysis, any kind of analysis, because as long as it is SQL and ANSYS compatible, we can do that record in here, right? We did the same thing with MongoDB, and you want to check with that. You want to check in that Hackaday, and you see the response. We're using Cassandra, and we felt very limited with ad hoc queries once we started doing Cassandra. And I walk you through to see the difficulties in action, and we saw how we brought Spark in for analytics. And with Spark as a full platform for analytics, machine learning, streaming, you see that it's not only for analytics and reporting anymore. You can push your boundaries into machine learning by pulling this data in, playing around with them data frames, performing machine learning algorithms, storing the data back into Cassandra with a read consideration, having your applications pick up this Cassandra with the same kind of speed and scale, and using them in a full cycle of data-driven enterprise, right? So of itself, Cassandra looked very suited for only a particular use case, but when we bring it into a full fully to a full data platform powered by Spark, we see that the possibilities just become like limitless. However, if you want to keep doing your read and write within Cassandra, if you want to do still that feature, then you have to really focus on the design. It does not mean you ignore design if you're going to use big data. It just means that you are going to give less upfront. For example, if we go to the configuration parameters, I can determine that you can see different configurations that you want to use, and I can determine that I want to do I think this should be predicate, right? Predicate. Yeah, the push downs. So you want to do push downs, you want to do class mappings. For example, Cassandra supports user-defined types. I want to map those types to probably Scala case classes. Those are also possibilities. And so it can contain simple use cases and even complex use cases. And you can use all these in your Spark application using data sets and data frames as well. So if there isn't any question, I think you've been able to see use cases of using NoSQL databases and Spark for write workload, for analytical workload. MongoDB is another guy you can use in the IoT space. Pretty fast, flexible, consistency level as well. In that one, we used things called write concerns. So flexible data, flexible consistency level, but you see it has a different replication architecture. It uses master slave. Cassandra uses peer-to-peer. So there's no single point of failure, right? And that is why it opens up the high availability option. Yep, and that is it for this Hacker Day. Hope you've enjoyed the sessions. You can take the test items as a task, hit it, use the same way we've done the test results. You can use the same method for test item. If it's proven difficult because it's failing, I would advise you to copy it out into one rough note, right? Simple to use rough notes, and execute it line by line in a shell, right? That will make things easy for you to see exactly where the pain points are, and you're gonna see it come through, right? So until I see you next time, where I think we should use Cassandra, the next, if I give you a heads up, we're going to use Cassandra in a streaming context, so you can see this is batch Cassandra. How about streaming? How do we use Spark structured streaming, or using Kafka Cassandra connector? That's another awesome use case. How can we use Spark, Kafka, or Spark Kafka with Cassandra, or Cassandra Kafka Cassandra, or Spark structured streaming Cassandra? These are all the possibilities that you can use for data in motion. But until then, I think enjoy this, complete the project, see it to the end. It takes time. Just execute it and walk away. Come back and see the results. It took about 20 something minutes for this to run, and the other data set is even more. Let's see what. Yep, it's even a lot more. If you have any questions, you can still use the appropriate Desire channel to ask the questions. I have actually run it to completion, but we cannot do that now on a single node given the time limits we have. So pass the questions. I'll be glad to answer them, and see you in the next Hackaday session. Thank you.